Okay, this is your Unit 5 study guide. This is the last unit. So after this, we're going to be going into the cruise, which is good news. All right, Miguel wants to record the number of sixes he rolls throughout throwing a fair die 5 times, 15 times, 50 times, and 100 times. With which number of rolls will he likely come closest to getting a 6 about 17% of the time? Now remember, getting a 6, rolling a 6 is 1/6 of the time, right? So there's one number 6 on the die, and there's 6 total sides. So if you turn that into a decimal, it's 0.16 repeating, which is really just 17%, right? If we doubled it. So it's saying how many times does he need to get to that? So this is the theoretical probability, right? But they're asking about, he's actually going to sit there and experiment. Now remember in the flip video, we talked about the more times that the more data points you have for your experiment, the closer it gets to theoretical. So therefore, the more times he rolls the die, the more closer he's going to get to the theoretical probability. So my answer would be A, 100 times, because that's the greatest amount of times that he is going to roll the die. Number 2, Jorge tosses a coin 50 times. The results are shown below. What is the theoretical probability? Okay, you got to be careful. Remember, this is data. Data is experimental. They're asking us just straight up for the theoretical probability. So the theoretical probability of flipping a coin and it landing on tails is one side is tails, there's 2 sides, boom, 1/2. Okay? Don't be tricked just because they gave you a data table. Number 3. A student registering for high school classes must take either biology or chemistry or earth science, and algebra, geometry, or pre-calculus. How many different schedule choices does a student have to choose from? So that's the fundamental counting principle. So the first thing I need to do is say, okay, biology, chemistry, or earth science. So I have 3 different sciences that I can take, times algebra, geometry, or pre-calculus. That's 3 different math classes I can take. Therefore, 3 times 3 is 9. So I have 9 different combinations of classes. All right. What is the probability of flipping a coin 2 times and getting tails twice in a row? So the first time you toss it, the probability of getting tails is 1/2. The second time you toss it, the probability of getting tails is 1/2. Now I just multiply across. 1 times 1 is 1. 2 times 2 is 4. So 1/4. All right, number 5. Jake has a bag of 3 red candies, 2 brown candies, and 6 blue candies. What is the probability that Jake will pull out a red, place it back in the bag, and then pull out a brown candy? All right, so the first one that we need to do is red over total. So there's 3 red over a total. Let's go ahead and find our total. So our total is 3 red plus 2 brown plus 2 blue. So that would be 11 total. So 3 over 11 is red. Then it says you replace the red back in, so we still have a total of 11. And now we want to pick out a brown, and there were 2 brown. Now we just multiply across. 3 times 2 is 6. 11 times 11 is 121. C. Alrighty. Virginia is the birthplace of the 8 United States presidents listed below. So here we go. If the name of one president is randomly selected from this list, what is the probability the first name will begin with the letter J? So what I did, I said, okay, James Madison, that starts with a J. James Monroe, that starts with a J. John Taylor, and that's it. So 3 of the presidents had a first name starting with J, and there's a total of 8 presidents. And lucky for us, that's already reduced. So G is my answer. All right, 7. The 4 graphs below display the distribution of scores on a math exam. Which graphs could be used alone to determine the number of students who scored a 92 on the math test? All right, so the reason that the histogram is not 1 is because 92 lies in here, but we don't know exactly how many scored a 92. We just know that 6 people scored somewhere in between a 91 and 100. So that does not tell us exactly how many people scored 92. If you look at this line graph, you can see right there exactly 4 people scored a 92. So that's a winner. Exam score, so 92, 1, 2, 3, 4 people. So this is a winner, tells you exactly. And then over here in the circle graph, it's similar to the histogram in that we know that the 92 percenters are somewhere in there, but we don't know exactly how many if we're just looking at the circle graph. So that does not work. Therefore, my answer is 2 and 3. So B. All right, using the letters A, B, C, and D, how many different 3-letter license plates, so 3-letter license plate combinations can make it if letters can repeat? So I have 1, 2, 3, 4 letters. So I need 4 in each one because they can repeat. So 4 times 4 times 4 is 64. All right, 9. This histogram shows the weekly hours. Which statement must be true? A total of 3 people spend 15 hours on homework per week. That is not true because we know that 3 people spend between 11 and 15, but we don't know if it's 3 11s, 1 11, 1 12, 1 13, whatever. So that is not true. Students who studied 1 to 5 hours will be represented by the largest sector in a circle graph. That's also not true because the largest sector will be 6 to 10 because that's the greatest frequency. On a line plot of this data, 6 hours will appear most frequently. Once again, we don't know that. We just know that 6 to 10 hours will appear most frequently. We don't know exactly how many students studied for 6 hours on homework. So we know it's got to be J, but let's prove it. Less than 15% of a circle graph of this data will represent the students who studied 11 to 15. All right, so 11 to 15 hours is 3 people. 3 over, we have a total of 8, 10. So 8 plus 10 plus 13 is 21 total. We could reduce that to 1/7. Now I need to turn it into a percentage. So 1 divided by 7 is 0.1428 ... I double dip over to get me 14%. And let's reread J again. Less than 15% of a circle graph. Yep, so it's going to be 14%. So that is less than 15%. So J is true. Is there anyone? Oh, okay, 18. The line plot shows the number of students per classroom. So they want us to break them up into intervals. So 26 to 27, there's going to be 3 people. 28 to 29, it's going to be 4 people. 30 to 31, it's going to be 3 people. And 32 to 33 is 1. So my greatest interval, highest frequency, will be the 28 to 29. Here we go. All right, the histogram shows the number of students in the library's book club. How many students are younger than 22? So they have to be younger than 22, which means they can't be 22 and older. So they've got to be all these people. So this is 3, this is up to 10, this is up to 15. I just add them up. So 13 plus 15 is 28. All right, next one. Based on customer feedback, manufacture wood blocks for children, blah, blah, blah. Okay. The same manufacturer wants to sell a 30-piece set. How many inches long will about 29% of the pieces most likely be? All right, so this is 2, this is 8, and this is 4. So this is what I did. I said, okay, there's a total of 14, right? So I thought to myself, around 25% of the data, right? Because 29% is pretty close to 25%. So if I did 8 over 14, that's 50%. So that's not going to happen. 2 over 14 is 1/7, which would be about 14, 15%. So then I tried this section. Y'all can come in. It's going to be 4. So now I can divide both sides by 2 to give me 2/7. So 2 divided by 7 is 0. All right, so if I do 2 sevenths in my calculator, I get 0.2857 dot, dot, dot. We double dip by turning that into a decimal, which gives us 28.5%, which rounds up to 29%. Therefore, they would have to order the 11 to 15 inches, which would be C. All right, next one. All right, the stem and leaf plot shows packages by weight. What package weight in the data set is the heaviest? So we need to figure out which is the heaviest. So we go down here. If you look at the key, it says 11, line 2 means 11.2. So this means 14.0. Therefore, D is our answer. All right, what percent of nights did Hugo sleep at most $7? So at most, you got to think to yourself, if you go to your mom and you say, I need at most $7, that means you need $7 or less. So at most means 7 or less. So I go to the 7 and I'm going to go to the left because that's less. So that's what I'm going to be focusing on. So from here it's 3. Okay. From here it's 11, 12, 3, 1. All right, so less than 7 would be 3 plus 11, which is 14, over the total would be 14 plus 12 is 26, 29, 30. Okay, now we need to make that into a percentage by dividing. And then double dipping. Boom, boom, 46.6 is the same thing as 47%. Alrighty, let's see up here. All right, which of the following can be constructed from the histogram? At the least number of hours Hugo slept is 0. So that's not true because there's no data there. So cross it out. Hugo slept 4 to 5 hours on 3 different nights. So 4 to 5 hours, 3 different nights. That looks good, but let's just keep going for fun. Hugo slept 13 hours one night. We don't know. He either slept 12 or 13, so that's not true. The average number of hours he slept each night was 9. Now we can't say that. It looks around 9-ish, but it could be 8, could be 7, could be 6, because we don't have exact data points. So that is also not true. Okay, the production records of a toy manufacturing company shows that 8 out of every 300 toys, 8 out of every 300 have a defect. Well, that's not good. What is the probability that a randomly selected toy manufactured at this company will have a defect? All right, let's turn it to percentage. So 8 divided by 300 gives me this. And a double dip. So 2.6 is the same thing as 3%. Next one. Okay, if Luke spins a spinner, like the one shown below, 64 times, how many times should he expect to land on this space with the square? All right, if you look at the square, I understand there's only 3 sections. However, the square takes up half of the spinner. So you have a probability of spinning the square half of the time. So you could do fancy math and turn that into a percentage or turn that into a decimal. But really, let's get real. What's half of 64? 32. Okay, or you could say 1/2 is 0.5. 0.5 times 64. And I promise you in your calculator, you'll get 32. Okay, the results of the die. What is a theoretical? Remember, when they're asking you for theoretical and experimental, start with theoretical first, because that's where our brains naturally go. So they want us to talk about rolling a 5. There's only one side with the 5 on it, and there's a total of 6 sides. Done. Now let's go to the experimental. So the experimental would be, here's the 5, so 10 over, and there was a total of, I think it said 50 rolls, right? Or no? Let's go ahead and add them up. So you're going to have to add up all of them. So 13 plus 9 plus 20 plus 8 plus 8 plus 10 plus 15 gives me a total, oh, I was completely off. Total of 83, is that right? There's no way. Hold on, let me do it again. 13 plus 9 plus 20 plus 8. No? Oh, 75. Okay, sorry. I did something weird in the calculator. Divide top and bottom by 5. And that gives